All right, guys, today we're talking about percentages, and a lot of this is going to be a review. A lot of this you've seen ways of solving some of these problems. In fact, I've taught a few of you how to do these in different ways already. But we're also going to look at some new methods and some formulas that you may have not seen before. And what we're really, here's where our concern is. This comment right here, the rate of e-cigarette usage among middle school students was up 36% to 5.3%. So it went up 36% to 5%. So before it was a negative percent, which isn't what it's saying, but that's kind of what it sounds like it's saying. And depending on what you're trying to convince people of this convoluted statement, even though it's completely accurate, it's pretty ambiguous at best. So what we want to do is be able to analyze these statements that you're going to see in your life and make sure that they're saying what you think they are saying, and that you're not getting tricked into something else. So first thing I need you to do, pause the video and read over this review of percentages. It's stuff you've learned, but it's things that you need to know. I'm not going to cover them as we go through this class. So if you need to take notes, if you need to remind yourself how to convert from one form to another, go ahead, pause the video, write down anything that you need. And when you're ready, unpause. All right, moving on. If you have any questions about any of that information, we'll talk about them in class. But percentages as fractions. Again, this is a little bit of a review. We'll go through these problems kind of quick. But this first example says an opinion poll finds that 35% of 1,069 people surveyed said that the president is doing a good job. How many said that the president is doing a good job? So back in 7th grade, if you had me, you saw something like part over whole is equal to percent over 100. If you had Mrs. Ledbetter, you might have seen is over of equals percent over 100. The is and the of refer to where things are placed in the problem, which works a lot of times, but really we're just taking a part of a whole amount. And in this case, what you would have done is said, okay, I've got 35%. And remember that percent is just a fancy way of saying divide by 100. 35%, 35 divided by 100 is equal to the part of the group over all of the group. Well, this 1,069 is all of the people that they asked. It wants to know how many were the 35% that said the president's doing a good job. You cross multiply, you divide by 100, and you get something probably 300 and something. Okay. You could also, of means multiply. So when you see 35% of 1,069, that means 0.35 multiplied by 1,069. You multiply those together and you get the same thing. Maybe we should see what that actually is. 0.35 times 1069. So 374.15 people, so approximately 374 people said that this is the president's doing a good job. Now, depending on what I wanted to convince people, I could either use this number or I could use the percent. I could say, hey, 35% of the people say they think the president's doing a good job. Or I could say, hey, only 374 people said that he's doing a good job. So you got to be careful how that data is used. Okay. In 2015, there were 61 million Americans under the age of 15 and a total of 321 million Americans. So total is 321 million. 61 is the part that we're talking about. If I wanted to know what percent are under 15, then I'm looking for the percent out of 100 that are under 15, the 16 on top. So I cross multiply, I divide by 321, and we can go ahead and do that. 61 times 100 is just 61 with 2 zeros. And then if I divide by 321, I get about 19. So X equals about 19. And remember that represents a percent. So about 19% of Americans are under the age of 15. according to that study. Okay. We can also use percentages to describe how things change. We can talk about like price of gas. In 2002, for a tank of gas, it used to cost me $16 to buy a tank of gas. In 2020, that same car costs about $40 to fill up a tank of gas. So we can say, I want to describe how things has changed, not just from $16 to $40, but what is that percentage? How much is the percentage changed? And there's two different ways that we can look at change, and we got to be careful for both of these terms, absolute and relative. Absolute change is the number or the amount that something changed, not the percent. The absolute change is the number or amount that it changed. The relative change is going to give us a percentage. It's the percentage that something has changed. So when I do a problem, if I'm looking for the absolute change, I'm looking for how much something has changed. I take the new amount, this is just the new amount, and I minus the old. My reference value, that just means my old amount. So this is my new, this is my old. So I would take 40 and just minus 16 and get 24. So the price of a tank of gas has gone up because this is positive. It's gone up $24. Well, what percentage is that? What's the percent that it has gone up? Well, now I have to use the relative change formula. So the relative change, again, this will give you the percent of change. You take your new, you minus the old, just like we did before. But when we're done, we have to then divide by the old, and we're going to times by 100. We're going to times by 100, and my answer is going to be left with a percent. I don't like that they put times by 100% because you don't. You times by 100. So new 40 minus 16 divided by 16 is equal to, oops, not equal to yet. I'm getting ahead of myself. Then I've got to times that by 100. And that's going to give me my percentage that things changed. So if I do 40 minus 16, I'm going to be careful to hit enter. And then I'm going to divide by 16. Hit enter, times by 100. And it tells me that gas has gone up 150%. That means it's 150% more than it was before. And I know it's more because my percentage is a positive number. Okay? So this second example, population of a town increased from 50 to 70,000. So this is the old. It went from 50 to the new 75,000. What's the absolute and relative change? So my absolute change is my new 75,000 minus my old, nope, not 25. I'm doing math in my head. 75,000 minus 50,000. And then I have to divide that. Oh, we're doing absolute. We don't divide. Oh, I'm all flustered. Okay, 25,000. My absolute change is I increased 25,000 because this is positive. Now my relative change, it wants a percentage. So I still do the 75,000. I still do the new minus the old. But this time I have to divide by 50,000. And then I have to multiply by 100 to get my percent. So I'm basically doing the same thing, but I'm going to take my 25,000 and I'm going to divide that by 50,000, which you should be able to do in your head, right? That's a half. So 25,000 divided by 50,000. And I added an extra zero. Oh, for heck's sakes. 25, 1, 2, 3. Divided by 50, 1, 2, 3. Guys, math is hard. Should give me 0.5. Times that by 100. Not 1,000. Oh my heck. 25. This is what happens when you try to do math on a computer. Times by 100, and I get 50. I'm increasing by 50%. So I'm taking 50% of my old amount, and that's how much I'm going up. Okay. And again, I know I'm going up because this is a positive value. Now, if I'm looking at population growth, if I increase from 2.7 billion to 7.5, so this is the old, this is the new, describe the absolute and the relative. So absolute is my new 7.5 minus my old 2.7, and I get what, 4.8 billion. There are 4.8 billion more people than there were in 1953. Relative, or in other words, well, what percentage is that? How much did it go up relative to what it was before? I still do the 7.5 minus 2.7, but this time I divide it by the 2.7 and then times it by 100. So I'm going to get, and this is in billions, remember, 7.5 minus the 2.7, enter, divide that by 2.7, enter, times that by 100. 177.77. So 177 point, let's just round it to 8. So it has gone up 177% compared to what it was before. That's almost 200% more that it's increased. Okay. We can also find out how much something has depreciated or gone down. So you bought a new computer 3 years ago. It was $1,000. Even though it was a new computer, it's the old, it was 3 years ago. So this is the old amount. Today it's worth only 300. So new today, it's only worth 300. Describe the absolute and relative. So absolute is the new 300 minus the old 1,000, and I get $700. My relative is that 300 minus 1,000 divided by 1,000, and then I have to multiply that by 100. So 300 minus 700, negative 700, guys, come on. Negative 700, when I divide that by 1,000 and then times it by 100, then negative 700, divide that by 1,000, and then times it by 100. So really, we're just dividing by 10. You get negative 70%. That negative means that I went down 70%. So depending on the question and the way it wants you to put in your answer, if it just wants the percent that it changed, negative 70%. But if it gives you a blank and then says decrease, you better make sure you just put the 70% there. The negative is what gives it the decrease. So be careful of that one. All right, percentages as a comparison. So we can use the same formulas to compare two different things to each other. We've just got to be a little bit careful when we do that. So in the example, we're comparing the money that people make in California to the money that people make in West Virginia. But depending on how I phrase it, we've got to be careful which is our first and second value, okay? So the way that we do this, the reference value is what we are being compared to. So this is whatever goes here is what I'm comparing to. So in this case, it says how much lower is the average income in West Virginia than in California. So it's taking West Virginia and comparing it to California. And I use basically the same formula. The absolute is just how much has that gone down. So I take West Virginia, or I take not how much has it gone down, how much does the price difference? So 46,600 minus 68,900 is going to be my absolute difference here, my absolute change. So 46,600 minus 68,900 gives me negative 22,300. Or in other words, West Virginia on average is $22,300 lower than California because it's negative 22,300. So if I wanted to find my relative difference, well, in relation to percentages, I do the same thing. But this time, I'm looking for the percent. So I have to divide by my second value, my California. Nope, extra zeros, guys. And then I've got to times by 100. So I'm going to take that. I'm going to divide my answer by 68900. Enter, and then I'm going to times it by 100. Not 1,000, 100. So it's 32% what? Lower, right? Because it's a minus 32%. So West Virginia is 32% lower than California. Now here's how why we have to be careful. This Mercedes Lexus example, the first one, they compared the Mercedes costs 25% more than the Lexus. Well, if I had switched my comparison around, instead of the Mercedes to the Lexus, if I changed it, the Lexus to the Mercedes, the Lexus costs 20% less than the Mercedes. So depending on what my end game is here, if I want to sell the Lexus, I can use one of these to help. I can say, you know what? The Lexus is 20% lower. That sounds pretty good. But I can also say, hey, don't buy the Mercedes. It's 25% more expensive than the Lexus. You've got to be really careful how people word this because both of them are true, but this one looks bigger. It looks like the Lexus is a bigger deal than this one does. Even though it's the exact same thing, it's just the order that they're comparing it in. So if I had done that mathematically here, all I would have done is said I would take California and minus West Virginia and then divide by West Virginia and times by 100. So the top is going to be the absolute. When I do the relative, that's going to give, when I divide by this, it'll give me the relative. So I can do both of them almost at the same time. But look at what happens. If I take 68900 and I minus 46600, again, I did an extra zero. Oh my heck. 68, I'm clicking now, 00, minus 46600. I get 22,300, right? So it's 22,300 lower. Well, that's the same. That didn't change. Or sorry, it's 23,000. It's a positive, so it's 22,300 higher. That's the same as this being 22,300 lower. But look at what happens when I look at the relative, when I look at the percentage. So if I say, now let's divide that by 46600 and then times by 100, that's 47%, 47.8% bigger or more. So if I'm looking at it this way, it looks like there's only a 32% difference. When I look at it this way, it looks like there's a 47% difference. Both of them are true. You just have to be careful about the wording that is used to convince you of whatever they're trying to convince you of. So if I was trying to convince you that West Virginia needs to make more money, I'm going to use this one down here because that looks worse. I can say California makes 47.8% more than West Virginia. Whereas this one, I'm comparing it to California. So this one says, oh, well, West Virginia is making 32% less compared to California. So we like this bottom one if we're trying to sell the fact that West Virginia needs more money. Okay, of versus more then. We're going to talk about this in class. You can pause it and read through if you're working on the homework at home. Be really careful of this idea because you need to know what it means to switch from an of to a more than, because there's a pretty common mistake that happens. The other thing that we're going to talk about in class is if we're taking percentages of percentages, we want to be careful that we don't mix up all of our percentages. It gets confusing. We'll do that one in class. Last thing that we want to talk about here, or I guess the last big one, is solving percentage problems, like dealing with tax or sales or discount. So this is what you're going to use if you're dealing with taxes, if you're dealing with sales, discounts, that kind of stuff, okay? So it gives us a formula. It says that our final value or our final price is equal to 100 plus whatever the percentage of increase is, multiplied by our starting value. Okay, so for example, because that to me looks like nonsense, you purchase a t-shirt with a labeled price of $17. That $17 is this value right here. That's my initial value. The local sales tax is 5%. That 5% is this P right here, 5%. What's your final cost? So I'm looking for my final value. So X would equal 100 plus our percent of tax, 100 plus 5%, and you would multiply that by our initial value. So that's $17 that we started with. So what you end up doing is getting X equals 105% multiplied by 17, which equals 1.05 times 17, which is going to equal what? 5% of 17 is going to be like 80 something cents. Let's see. Let's go 1.05 times 17. So we should get the $17 plus, about 80 cents, 85 cents. So your new price is $17.85. So now back in 7th grade, we just found the 5% of tax and then added that to the original price. You can still do that. You can take 5% of 17 and you would get 0.85, and then you could have added that to the $17. That still works. This is just another way to do it. Part B, your receipt shows that you paid $19.26 for a phone case, including tax. So that's my final value. That's how much I paid, $19.26. The local sales tax is 7. So 100 plus my tax went right here. What was the pre-labeled price? So what was my original price before I paid tax? So that becomes 19.26 equals 107% plus X times X, not plus X, times X. I'm like, wait a minute, that doesn't sound right. So multiplied by X. Well, to get rid of 107%, I've got to divide by 107% on both sides. So 19.26 divided by 107%, or 19.26 divided by 1.07. So on my calculator, 19.26 divided by 1.07 gives me $18. So before tax, the original price was $18. I found my initial value. Okay. Now be careful with discounts, because discounts, if you notice this little note right here, if the final value is less than what we started with, instead of the 100 plus P, we want to use the 100 minus P. Okay. So for example, in part C, you're eligible for a 15% discount on tickets that normally cost $55. So I'm looking for how much I'm going to pay. Well, normally we would do 100 and add the tax, but we're getting a discount. So I'm going to do 100 minus the 15% discount. And that's going to be multiplied by my initial price, which is $55. So my price would be 100 minus 15, that's 85% times by 55. So that's 0.85 multiplied by 55. So what's my paying price going to be? 0.85 times 55. $46.75. So instead of having to pay $55, your 15% discount means you pay $46.75. Okay? We'll do some more of those in class. Just be careful that if you're getting a discount or your initial value is going down, that you use the 100 minus P inside of these two formulas. All right. I think that's enough for today. Go ahead, jump on the homework. You're welcome to, this one is homework, this is unit 3A. You're welcome to start it at home. We'll do a lot more examples in class because there's 100 different versions of this type of problem.